Okay, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. Right, I'm Trevor Eddles. I'm CEO of a company called iTechEd Limited, and we're a mainframe consultancy, analysis and technical authoring organization. And we're responsible for the content on the virtual IMS website and in the newsletters and on social media as well. So first of all, then, let me run through the agenda. As usual, most of the meeting will be taken up with the presentation, and today our guest presenter is Scott Quillicy, Senior Director for Precisely, and his talk is entitled Lessons Learned, IMS Application Modernization to the Cloud. And a copy of the slides from this presentation will be on our website later today. And by the way, if you've missed any of our previous meetings, you can download copies of the presentation from our website and you can listen again to the whole thing. And there's a link on our resources page. Following Scott's presentation and any news, any questions you have for him, we'll move on to the latest IMS news, latest IMS related articles, and then I'll give you the dates and times for the next virtual meetings. So that's the plan. And I'm anticipating that today's session will last just under an hour. Anyway, as I just said, today's presentation is from Scott Quillicy. Scott is a Senior Director for Precisely, formerly SyncSort, with just over 40 years experience with IMS and ZOS data integration. Scott was a co-founder of SQ Data, which was acquired by SyncSort in 2019, and he's known for its high-performance change data capture solutions for IMS, DB2Z, and vSAM. Scott is considered a leading authority of database replication strategy and deployment and stays actively involved with large IMS-related initiatives worldwide. So, Scott, I'd like to thank you very much for being with us today. And what I'm going to do now is stop sharing my screen and let you share yours.
All right. Well, thank you, Trevor. It's always a pleasure to present to the virtual IMS user group. What Trevor was saying, 40 years just means I'm old. So I've seen it. I've been around the block a few times. Okay, so this is this year's incarnation of lessons learned. So I was looking at my previous presentations, and it's usually lessons learned up to that point. So we're going again. This is what we learned over the last 12 months. Any questions Trevor and I talked about earlier, raise your hand and we'll take them as we go. If you do have any questions.
Sorry, oh yeah, people can just type into the chat box and I'll pick them up from there. That's probably the easiest thing to do, Scott.
Okay, that sounds great. Very well. Well, here we go. So what we'll talk about today is recap last year's lessons learned, talk about application modernization from a data perspective. We're not going to get into all the details of data modernization or application modernization. There's a lot to it. We're concerned with the data, particularly IMS, right? Talk about current trends and directions, and then throw in a few tips, hints, and best practices as we go through. So who's this guy? Who am I, right? 40 years, officially 40 years. So December 2022 was 40 years exactly. That just says, like I said, I'm an old man, been doing this for a long time, 30 plus years just in data replication, starting with the IBM tools. I was fortunate enough to be thrown to the wolves right out of the gate, right out of college, thanks to assembler. They found out I knew assembler, and here we go. So IMS 1.2, planning to migrate to DBRC, big deal, DBRC back in the early 80s, and then got started with DB2 1.2 in 1984. So fortunate to be in that space. And again, I thank my instructors for focusing on the assembler. Like Trevor said, founded SQ Data in 2000, right about the time the internet bubble burst, so timing wasn't great. It really wasn't planned, but it worked out. The intent was to address shortcomings in mainframe data replication, particularly IMS. The tools that worked with before were not great, and we knew we could do a better job. SQ Data was acquired by SyncSort in 2019, and it's been a good run ever since. It's a good group. You know, the mainframe specialization was Sort, solid team. And so I get to spend most of my time working with large cloud data migration projects. A lot. Keep people from making common mistakes. So I'm usually brought in up front and help implement best practices. So kind of guide you. We see common mistakes, and we'll go through some of those as we progress through the presentation. Okay, some of the terminology I'm going to use, I guess you guys know source and target. Streaming is replicating IMS updates off the mainframe to a streaming target. We'll talk about that. Tokenization, masking PII data sensitive information. Forward sync. Okay, so forward sync is the streaming from mainframe to distributed targets, and then reverse sync is streaming the other way around, back distributed and cloud to mainframe targets. And telemetry is just something you'll hear. It's has to do with observability and monitoring, and we'll go through one slide on that. That's a whole different discussion by itself. So what does mainframe modernization really mean? Like, what does it really mean? So what we're seeing is it migrates workload from the mainframe to the cloud. And it is pretty much the cloud. There is some on-premise modernization, but really most of it's not. It ends up in one of the major cloud infrastructures. Major core applications now. We're talking about core financials for the banks, insurance. This is not just a one-off little app. I mean, those are certainly going, but the major apps are now starting to migrate. And each one of these has a very high transaction volume. Usually, some of our higher volume customers are over 1 billion updates a day, 1 billion updates a day. How's that going to work in the cloud? We'll talk about that. The application strategies for actually modernizing, you really have three major. It's a lift and shift. You might have heard about people going lift and shift, where you can run your apps unchanged on Linux using a framework like Micro Focus. They have a IMS component. It works. And for the most part, lift and shift does work. It's never, 100%, but it's pretty close. The second strategy is refactor. So refactor is converting COBOL PL1 to a cloud friendly, like a Java. Blue Age does this. It's a very common converter. And so they'll convert legacy to more modern Java. And the same functionality exists. The third is where I kind of get involved. I see between the second and the third is a complete redevelop or full refactor, depending on who you talk to. That's where they're completely modernizing the application. So it's a rewrite for the cloud. That one poses more challenges. Obviously, it takes longer, but I think the benefits are higher at the end of the day. As far as data goes, bulk data transfer and data replication are critical. Data replication is absolutely critical for this kind of modernization. Latency becomes really important. Before anything, 2 or 3 minute, like 2 or 3 second latency was okay. Not now. Latency has to be low sub-second. And then two-way synchronization, meaning reverse sync and forward sync, are requirements. And I've got more to talk about later in the presentation. For the purpose of this discussion, though, we're talking about data. We're not going to talk about the app side of it. Okay, so in the AWS world, one of the major players we work with, this is the major phases of modernization. So they're going to go through the analysis, determine whether to refactor, replatform, redevelop, go through the deploy, and then you get into operational. It's usually done in a phased approach. Lift and shift, sometimes it's done all at once. Most of the time, though, not. We see a phased approach. That's why data replication is so important. In December of this year, SyncSort, or Precisely, I keep calling them SyncSort, signed an agreement with AWS to be the go-to mainframe data integration tool. So that includes IMS, DB2, and vSAM. And pretty proud of that one because it was really the SQ data technology under the covers. So, that's a definite feather in the cap. So a lot of the examples I'll be using are from, using the AWS cloud, but it applies to the others as well. So what are the advantage and disadvantage of cloud? The advantages are cost reduction for the most part, physical space. You don't have the data centers. You don't have to, get servers, high price software that you have licenses for, and the support personnel. So significant there. Tools, there are a lot of tools out there and they're more every day. So the beauty of the cloud is you can use what you need, even if it's with competing products. And we see that a lot. You avoid shelfware too. If you're not using something, you don't need it anymore. You don't have to pay for it. So it's a pretty nice setup. It's more efficient. Security, from an infrastructure standpoint. So these data centers are fully secure. They must comply with industry standards, and it's less prone to insider theft, which we found out is probably the biggest contributor to intellectual property theft. Reliability, it goes without saying, built-in redundancy. Most providers guarantee 99.99% uptime, which is great. And the technical skills also are plentiful. So you're talking about Python, Java, JavaScript. I mean, those skills are a lot more plentiful than what we're used to on the mainframe side. Now, the disadvantage is cost creep. It's cost reduction, but it's not free. And if you go crazy with it, it can be expensive. It could rival Zed, I think. The compute resources by itself, and then we find that these departments have a cloud, and next thing you know, management's saying we're spending too much on this stuff. So it can creep up. It's not a one-time, it starts off slow, but it can grow. So be careful with that. The downtime, if your internet goes out, everything is dependent on the internet now. And so if the internet link drops, you're out of business until it comes back. So that's that's a big one. Security, we'll talk more about that. It doesn't guard against weak digital security like encryption or tokenization. It's like leaving your laptop open at Starbucks. You easily done if you're not careful, and then you make the news. And for major financial companies, you don't want that. Performance, it's not as great, and we'll talk about that a little bit more too, especially for batch. It's not the same in complex transactions. They're not going to perform as well. They're just for a variety of reasons. And then cloud vendor lock, right? Vendors, including say AWS or Microsoft, they're going to encourage their stuff, not the generic. And so you get locked in. No different from what we've seen for over the last 50 years with software. And it's really difficult to move off once you're there. The major cloud providers, briefly, Amazon #1 with 34%, Microsoft's #2, and Google's #3. And we see in the rest of the 20 or 25%, we're seeing that about right. We see mostly AWS, a lot of Azure, Microsoft, and now Google GCP is coming into play, and we see more of that. To us, it's all kind of the same. It's just a second set of servers, and the rules are a little bit different. This is just a kind of a follow-on to the slide before that, where you have, where the interest is, and you can see it correlates with AWS being 1, Azure 2, and then Google Cloud 3. So, scenes from last year's episode. My wife and I do a lot of binging, right? So I put the little skip recap. It doesn't work, so we're going to have to go through it. So last year, we talked about the Great Divide, and you guys have seen my presentations before. This is a concept I have with mainframe versus distributed or cloud, right? There's a significant language barrier, culture barrier, different levels of discipline, pride of ownership on both sides. The talent pool is shrinking. especially in the IMS space, and it requires patience. I really put the burden on both sides to communicate and collaborate. There's really some friction, serious friction goes on between the two camps. Just know it's there, and it is a real thing. So lessons learned, the Great Divide, again, is a real thing. Mainframe expertise being in short supply, and IMS skills are really becoming scarce. Cloud is king. On-premise targets represent like less than 10%, pure on-premise targets. We'll be using one of the more popular frameworks is a semi on-premise cloud application. Modernization's hot. Moving off the mainframe is serious momentum. Some people are ready, some large companies, you'd be surprised, are ready to shut down their Z systems, which I never would have thought would happen, but not in this short period of time, but they're very close. I can't name names, but you might know them. On the technical side, again, cloud databases are really slow for batch. Scaling's an afterthought, and bidirectional is a more common use case. A little bit about data in the cloud. It's scalable for the normal transactions, like if you're doing credit card authorization or deposits, withdrawals, short transactions, small transactions. It's fast, it's scalable for the quick in and out. But the difference is the server where the apps run and where the databases you can't really control that in the cloud. So ping time's a major factor. We see ping time of 10 milliseconds. Well, 10 millisecond ping time, we measure with a calendar one. That lets you to 100 records a second. You can see where batch would be a problem here. Again, security concerns are high. High volume customers should include a streaming component and like a Kafka or Event Hub for scaling. And we'll talk about that in a few minutes. Considerations. In general, performance really depends on speed of the target if everything's good. So when you're doing replication, if you're doing, excuse me, I had to settle down. If your capture part is slow, you need to look for another tool. Really, if everything's running right, the speed of the target dictates latency and throughput. For application modernization, they want lower latencies. I said mid to sub-second, low sub-second. Higher volume guys are going to need to scale. And if the apply rate, the target's slow, that means you got increased mainframe back pressure, higher CPU usage, and then people come in, why is my latency so high? I mean, I've lived that for the last 12 months, and it's not fun. So 1 year later, current, the Great Divide's really getting in a hand now. It is truly a gap like this. The language barriers increased. We're seeing a lot of outsource on the mainframe side. It's there. And the talent pool is not only shrinking, it's disappearing. A lot of us are retiring. And not a lot of skills left. Mainframe in general, just how to submit a job. You wouldn't believe that's totally foreign to the cloud people. Lessons learned, pretty similar. The Great Divide really is a threat now that has to be taken into account. You have to have a good communicator. Somebody who can speak both languages is really, really in demand right now. Application modernization is not, it's white hot. It's well red hot here, but super, super hot. Seems like everybody's going that route. We're seeing the larger companies in the beginning stages. Some have already converted some, but nobody's done yet. Not really, and we see a lot. Okay, and then again, you can see batch workload is the big concern as far as speed in the cloud. And then now you do absolutely have to have a streaming component. You can go straight to like say IMS to Postgres, but in the cloud, if you have any kind of volume, you're going to need a streaming component. I mean, that's not even really a suggestion. You have to have it. Okay, this looks very similar. The biggest one on slow apply rate, we're seeing service level violations. So people are setting up service levels. We need 50 millisecond latency end to end. We'll talk about that in a few minutes. So latency was the theme of 2022. Is not only can you replicate, assumes the tool can do that. It's how fast can the tool do that. So as far as trends and directions, we want to set realistic expectations, and that's huge. So we've come into situations where they'll say, oh, we committed to 50 millisecond latency from the time a transaction commits an IMS until it's landed in the initial landing zone or even the final landing zone. And we'll talk about what that means in a minute. And we're just like, no, you can't do that. Now we've seen 50 milliseconds, we've seen 40, but on the average, depending on transaction size, depending on the number of bytes, you can look at mid to low sub-second, 150 milliseconds, maybe 200, maybe average 500. It depends on number of bytes, number of records. Batch won't be sub-second. Batch workload where you have 10,000 or 20,000 updates in a transaction, that might be a second or two, but you still need to be able to flow as fast as possible. Again, speed of the target dictates latency. Cloud slower, no doubt. And then again, I said highly recommended for the streamer. It's kind of like a requirement now. So the final solution is going to be software from multiple vendors, even competitors. So in the replication space, there's competing products we use, especially on the way back, the reverse sync back mainframe or cloud back to mainframe. From a streaming platform, Kafka number one by far. So there's multiple flavors. There's MSK, there's Confluent. At the end of the day, it's a more enterprise class framework for streaming. Azure Event Hub is okay too. I mean, that's Microsoft's, it works. Google PubSub, a distant third. But you'll see Kafka. We were asked about Kinesis yesterday, and that's okay. We just don't see that as enterprise class as much as a Kafka. If you have any questions, you can hit me offline on that. I've got some details on Kinesis versus Kafka. So a tale of two architectures. On the forward sync side, you've got two architectures, basically. You've got the fire hose, which is a continuous push. Say you have between ZOS and distributed, you have a 20 millisecond ping time. That's optimistic in some cases, that's low. Sometimes we see higher because just the number of firewalls and network hops from distributed to the cloud, 20 milliseconds is actually not a bad number. So with the fire hose approach, you're pushing all the changes as quickly as possible to one or more apply engines, who then update the target. And again, the throughput's going to be dictated by how fast you can go to the target. The second architecture is a ping pong, and you'll see this. It's called agentless. You'll hear people say agentless. What that means is that the apply engine has to ask for data, and then it comes back, and then ask for more data, and then comes back. We see that being a huge problem. Our architecture is a fire hose approach. You really want to, when you're looking at tools, agentless sounds really good, but from a throughput perspective, if it's not architected right, like a little mini fire hose within a ping pong, you're going to run into problems. You're not going to be able to keep up. And I'm talking about high volume customers, not the low guys. They can deal with a lot more options if you're low volume. If you're high volume, not so much. From a forward sync architecture, what we're seeing is this. So you have high performance streamers. In our case, we have the IMS publisher, and we're the same with vSAN, DB2, the same. Pushing to on-premise, right? And this is the major financial companies. They're doing this. They don't want anything to go straight to the cloud. Could you go straight to the cloud? Yes, you could. But if the data is in the clear, like personal information, number one, that is, nobody wants to make the news. Nobody wants to make the news. So they land on premise and then run a series of tokenization, filtering, whatever they have to do before it ever hits the cloud. This is what the major financial, insurance, fintech companies are doing. Even manufacturing, where there's sensitive auto manufacturers, for example, there is sensitive information in the call home app when the cars call home. They don't want that going straight to the cloud. You could, we do have customers that do that. The transformations on the fly, tokenizations on the fly, all that does is slows down the initial landing. You know, if it takes a millisecond, for example, to do a token, call a tokenization routine, then you're talking 1,000 a second records. When most of the time we're looking at 40, 50, 60,000 a second, that 1,000 is just throws molasses into the whole thing. So this is what we see as far as a popular framework for 2022. Now at the bottom, you'll see eventual consistency. Anytime it lands in a streamer, the data lands in a streamer, you lose your transactions. You can try to put them back together. Some people do that. I think the best practice is to accept that it is eventual consistency and everything will be in sync eventually. And we're talking milliseconds, not usually days or even minutes. So a little more on eventual consistency. Eventually it will be on sync. Now, the arrival rate, it can arrive out of order in a streamer target. Now, you got to make sure that for a single key value, like customer 123, they cannot come out of order. So you want to partition with the same partitioning key and have a good partitioning key strategy. So Kafka maintains order within a partition, but not across partitions. So between mine and Trevor's account, who cares who gets there first if they're not related? But anything I do or anything Trevor does needs to be in order. So keep that in mind. It's rule number one, has to be that way. Some folks, like I mentioned, try to use commit events. So they'll construct a commit, they'll write like a commit record and then go get all the transactions for it. We find that just slows things down, right? It does work, but it complicates things. If it's not like, especially for batch, good luck trying to go find 20,000 and then how long did that take, right? And it slows the data flow. So be careful. You know, it's cool to try to make, ACID type commit transaction boundaries in Kafka. It's best just to accept eventual consistency. One thing as far as the best practice is encourage people to carry timestamps. So even if the record itself, the data doesn't have a timestamp in it, carry a timestamp of the change at least, all the way down to the target. You'll thank me later for this. The reason is really it keeps things in order and avoids having to apply, older data on top of newer data. It's a concept we call smart apply internally, but you do it by timestamps. It's just an extra safeguard. Carry timestamps, just do. In our case, we use store clocks, the day by store clock, which is what, nanosecond precision. But, a timestamp works also. But between keeping things in order and carrying timestamps down to the target, you'd be, don't skimp on either one of those. Okay, a little bit on reverse sync, where we go cloud to mainframe. This scares a lot of people, right? You want to, the whole intent is to keep the legacy databases in sync with updates from the cloud as the application is shifting. So the trend that we see is during the initial planning, the very first part of the project, it's absolute requirement. We've got to have reverse sync. It's got to happen. Mid-implementation, it becomes more of a, we don't need all the data. We can do with some of it. And then toward the end, they're rethinking. It's just a scary, scary thought to have cloud come back and update your legacy databases. Only if required is what we're seeing. That's the trend. So the interest starts high and then plummets toward the end. It still happens, right? But it's not as large as the scope of when the initial project kicks off. At least that's what I've observed. So the rules, if you do this, there can only be one system of record. So if an account record is on IMS, it stays there. That's the source. You're not going to replicate changes from the cloud back to that guy. You're only one system of record, right? And you cannot share it across platforms. So You can say, well, system of records really in both places. Nope, no, don't do it. Don't do it. It's just nothing but trouble. If you get into some kind of where you replicate the wrong thing back, or even the right thing, you could be out of sync. So those two rules, they're non-technical, just make sure they're adhered to. You need collision detection just in case number one and number two, the system of record rules are violated. You have to know that it happens, and then good luck trying to fix it. It's not automatic. In the data context, people don't think about that. Is there enough context in the CDC data coming back to the mainframe that the applications will still work? You know, we'll say, well, we had 100 fields in the segment, and when we modernized, there's only going to be 30. Well, the apps won't work without at least 40, right? Or certain keys. So you always ask, what happens on an insert? What do we do on an insert? And then they just kind of scratch their heads and, will the app still work with this small amount of data and not the full context? You can do partial updates. That's doable, but it slows things down by at least half. You think about it, you got to read the record, lock it, pull the data you want, and then do the update. So it's going to cut it in half as far as throughput goes. I think it's the nature of the beast. You're going to do partial updates. Stay tuned, because as people go through this and we're running volume now, we'll keep you posted. That might be a 2023 lessons learned, Trevor. Just stay tuned. Okay, on the reverse sync, architecture-wise, same concept applies. You got the ping pong approach, where say the top one stays DB2. That's a really good example. Some people might want to use JDBC to do that. If you got 20 millisecond ping, you're talking 20 records a second, 20 for a single process, not thousands, right? Versus the fire hose type architecture. If say IMS can handle 5,000 a second for your workload, then that's what the apply rate is. You definitely want to avoid the ping pong. It's just, especially in the cloud where you're talking about, you know, excessive ping time between the components, and you don't really have any control over where they sit. Here's a sample reverse sync setup. And again, this is somewhat new. I don't know that anybody's really totally advanced in a high volume, like a financial app yet going back. And again, based on the trends, people losing interest as it goes along. This will be something we're going to be learning a lot about going forward this year. But what we see in the cloud is there's all these little CDC adapters. Say MongoDB has one, Oracle has 2 or 3. Well, Mongo has 2 or 3, SQL Server does. All the databases over here, the major ones have these, what they call source CDC sync. They could be from us. They could be from Debezium. They could be from Click/Attunity, multiple CDC sources. Salesforce has their own. But they all have these CDC syncs that put JSON or Avro generated CDC messages into Kafka. You can also go to files, but you lose your near real time when you do that. They go to Kafka. That further stresses the need for a streaming component. And so from that point, you have a publisher, we go the firehose approach, to one or more apply agents on the mainframe side that take those changes from one of these sources. It could be Dynamo, it could be a lot of different things, and then apply back to the mainframe, you know, IMS or vSAM through CICS or direct. And DB2 is probably the simplest one because it's just straight, you know, either ODBC if you're remote, and again, there's ping pong, but if you're local, then we just use native connector. Any questions so far, Trevor?
Sorry,
No?
I was muted. No, not yet.
Okay, well, if they do, shoot
Is there
them
a chat window? I'm not able to see a chat window.
Down at the bottom right-hand side where there's 3 little dots, if you click on that, then you'll be able to open the chat window.
We don't have it available at Bank of America.
Right.
Well, in that case, just unmute and speak up then.
Well, just speak out. You have any questions?
Yes, Scott, this is Prashant from Bank of America. When a legacy application on the mainframe decides hey, we want some data out of IMS to mid-range or cloud. Do they need to do any groundwork based on your analysis? Like, okay, my TPS is this much and my batch is so and so. I see that batch, when if it is heavy batch, that is a showstopper, right? Because 24/7 banking and your batch, that would create a major problem, isn't it?
On the way down, now I say the forward sync, not so much. We've optimized for high volume, including like your apps, right? You know, the same apps you guys run. It's not the performance isn't so much on the way down. It's when it gets there, right? So if they need data, say from a core financial app, you can stream that down and it will be in one of their targets, usually a Kafka target, it could be in Dynamo, it could be in Postgres. There's scaling involved to get there at the right speed, but that's not really the problem so much. We can handle that part. It's the replication tool should be able to handle that. It's what happens after that. So when you move that functionality to the cloud, say posting, right? That's a big one for any financial institution. How fast is that going to run outside of replication, right? But to get the data there quickly, yeah, that's not really the challenge. It's what happens after, right?
Okay.
This is a good question though.
Okay, because when BMPs are pounding, and of course, you know, it depends on what kind of a replication infrastructure you laid out on your side, on the mainframe side. That depends, as well as our assumption is, okay, you know, very good infrastructure on mainframe. It collected all the BMP updates and it has taken over and getting on the other side. I see that, okay, if we cross this challenge, you're saying that on the other side, how fast it can apply and spread it out is another challenge.
Correct.
Okay.
In the case of where you're having your super high volume transactions, what you want to do is land it quickly. That's where the streamer comes in. So let's say the Kafka Event Hub is going to be like a buffer, a giant buffer. When you're running your BMPs, you're probably running 80 or 90 wide, you know, each against their own partition. That's what we see in high volume batch. That's a very high transaction arrival rate. You're not going to be looking at sub-second latency, but it shouldn't be more than a second or two if you scale right. The trick is on the back end of the buffer. How many consumer agents do you have to apply? So for example, if going to Postgres in the cloud, we see a good number is 250 records a second in a normal setup. You can maybe go faster, but where you can get 2,500 on premise, it's 10%. So in order to get the arrival rate, you'd have to have the number of consumers set high enough to handle that throughput, right? It's just a math problem. But this infrastructure in the middle has to be solid like mainframe, right?
Gotcha.
You're talking about a fairly substantial setup because look what's happening on the mainframe. You need to be able to receive that. You can't just put it in a, you know, little weak component.
Gotcha. And Scott, one follow-up question. Did you see in your experience dealing with compensations or data getting out of sync? And are there realistic situations that when you get out of sync, how hard it is to sync back for a 24/7 application?
The answer is yes, it happens. You can get out of sync. You want to take as many precautions as possible. In the case of IMS, since you have a root key, no matter what, there's always a root key. Use that for the Kafka partitioning key. Don't use the full key of the record. Use the root only. And so any related record is in sync, right? And if you use the wrong keys, and it's usually self-inflicted, right? You use the wrong keys, then you're going to get out of order. And what's even worse is you're going to have a child show up before the parent. And that's bad. And so the same rules that happen on the mainframe, we keep everything in order. And any major mainframe replication tool is going to keep things in order. You just need to be able to make sure you're consistent with the keys. and you won't get out
Gotcha.
of order. Now, that said, if something bad happens, you need to have the rematerialization or initial load ready to go. Anyway,
Very good.
you're going to have to do it initially, but you want to avoid it, especially with like 20 billion records. You know,
Yep.
you don't want to do that every day. It might take 3 days.
There you go.
There's a strategy to do that. You know, the initial loads, but that's, you know, a subject for a different discussion, different
Right.
presentation.
Okay. Gotcha. Thanks, Scott.
You're welcome. Any others?
Yeah.
See some hands in chat.
Sorry, there's one from Arturo Juarez, quite a long one, so let me read it out. It says, how many EC2 servers are required to host one application in your experience? It goes on to say, I know it will depend on the application complexity, and I'm not talking about just one transaction, but about an application with multiple transactions that currently have sub-second performance response times to the end users.
Good question. So that's like kind of like saying how long is a piece of string? So you're right. You mentioned what does the app do? You know, how heavy is it? And EC2s come in different sizes, like, you know, small, medium, large. The replication framework, this part can sit on one. We've seen you'll have a standby. It on the cloud itself where the apps run. It depends on how high you're going to scale it. So you need to have like 2,000 concurrent or 500 concurrent, or, you know, what's the concurrent transaction look like? What does that look like? In the case of ATMs, there are going to be a lot of concurrent transactions, right? So I would think you'd be looking at multiple of the larger EC2s. You know, I mean, you have to just, you know, look at it by application. Their sizing. And the good news is if you pick slow, and we kind of want to do that, you don't want to pick the highest one and never use it all, but you can add to it in the cloud. So if you need more capacity, you can provision that capacity. So the suggestion is start with what you think you might need, you know, maybe a little bit small, and then grow from there, because you might find out that's just plenty. Again, it comes back to the application behavior. The goal, though, is to provide sub-second response back to the user. And you can still do that in the cloud with the ATM transaction or authorization. You can do that. It's achievable. Even with the ping times, you know, just make sure it comes down to IOs, really comes down to IOs. If you're doing 10 IOs versus 3, you know, the 3, you're going to get sub-second. The 10, you're probably right at a second. So anyway, yeah, it's cool. It's interesting. It's kind of interesting, the whole play and all the different variables.
Okay, Arturo says thanks. I've got a question from Brad St. Pierre. He's saying, are you seeing Z Linux being used on premise for good latency?
No, but I say no. Today, no, you could. Yes, you could use Z Linux. And there's a lot of infrastructure for Z Linux. So our tool supports it if you want to do that, but you know, you'd still have to install the Kafka. All this part in the middle, this could be Z Linux on premise just as easily. So we don't see that much. You know, we see regular because of the Great Divide. Remember the Great Divide? When you say Z anything, then the distributed guys just get glassy-eyed. Like, oh, no, not mainframe, right? Seriously, that's a big deal. You wouldn't think it would be if you showed them how easy it was to use, because it is easy. It's just like Linux that they're used to, but the fact that it has Z hooked on it, it just kind of freaks people out a little bit.
Okay.
But so, yes, I see that being a viable landing area, honestly.
The Z phobia.
Yeah. Yeah.
Okay, that's all the questions I've got.
Okay. Let me get back to where I was here. Okay, observability. You're going to hear a lot about this, and this is one of the cool things in the cloud. Again, this is a full different presentation, but it gets into telemetry, which is the gathering of stats, logs, metrics, real time streaming of log data, mostly. You guys know the tools that do that. Observability is to be able to drill down immediately and find out what's going on. Monitoring analyzes predefined stuff, so it's going to tell you like how far back you are, kind of volume. If a component's red, you know it's down. Then you can use the observability to go back. But this in the cloud is probably one of the coolest things. It's called OTel. You'll hear about it. Open telemetry is a commonly used framework. It's called OTel. So you mainframe guys, you just learned a new term for helping the Great Divide a little bit. But it's cool dashboards, real-time debugging, and a common framework for all the components, so they all use it. It's not like what we've seen, you know, on mainframe. You got like main view and Omega Mine, things you can use there. And then distributed has their set. Well, in the cloud, they're all hooked in. So it's a common framework, which I think is outstanding. More to go on this one. This is, we're being pushed. The reason I had to throw this in here is we're being pushed to be very OTel compliant. And any product that runs over in the cloud has to be that way too. So that's about it for 2022, guys. It's again, the latency. It's been all about latency. I've been pounded latency. Oh my gosh, one after the next. And some of you guys on the call know this because you were right in the middle of it with me. Set the realistic expectations up front. You know, low to mid sub-second is what, you know, sub-second usually works, and then somebody wants 50 milliseconds. Well, that's really, really micro low. Probably not going to be on the average. You're going to see them occasionally, but if you're looking at, say, even 75 percentile, you're not going to see 50 milliseconds from the commit, from the IMS commit until it lands. There's just too much going on. And even a 20 millisecond ping, well, there's, you know, half of it right there, and you didn't even do anything. It's just the distance between the different components. Again, speed of the target dictates latency and throughput. You want that. If the speed of the target is not the problem, meaning the capture is, he can't keep up, look for another tool. You can maybe scale it, depends on the tool. But the tools should be able to scale. We want to start with target side scaling first. You don't want to start on the source. You just don't prematurely optimize. You want to be able to make sure that the target is the bottleneck, and network is a bottleneck too. We've seen that, but that's what I would consider target when you're trying to push. The cloud itself really not terrible. You know, I thought, oh yeah, everybody's going to want to do this. They are, right? And it's not a terrible framework, as I've been indoctrinated. So in the Great Divide, I'm on that one side and I'm guilty. You know, I can kind of speak the language on the other side too, so I can go back and forth. But I was more on the mainframe side saying, yeah, who's going to want to do this? Well, it turns out a lot of people are doing this, and the major companies are doing this. It's scary though, if you think about it, because you have fewer data centers. And what if the internet drops? You know, I mean, people think about that. Every company, I foresee a trend. This is just me. I foresee a trend where people are going to start bringing stuff back in down the road. It's like an elastic band, you know, everybody goes to the cloud, then it's going to come back, you know. So it won't be totally off the cloud, but there'll probably be some coming back. Just be interesting. We'll see if that prediction holds true.
Is that the reason you used that last example where you are doing a reverse synchronization?
Yeah, that's
Okay.
the reason. Yeah, that's
Okay.
that's one reason. I think the other reason is the first time one of those major data centers goes out, because everybody's running. There's so much capacity, right? What's
Right.
going to happen when one of those data centers goes out, or the internet drops for an extended period of time?
Right.
You know, and they're going to say, well, if we had it in-house, right? That's just my prediction. I think highly likely that could happen.
Okay.
But if I could predict, I'd be betting on Super Bowls and, you know, World Cup. Man, I'm not lucky. As far as the mainframe folks, you guys, you play a critical role. You're absolutely required. Yeah, you're a pain in everybody's butt, right, on the distributed side. But without you guys, it's not going to work in the cooperation and being able to install, you know, the right framework, help monitor it. It should be a set and forget. if it's done right for the mainframe guys, which is a good thing, keep the back pressure off the mainframe, with, alerts, right? If something goes wrong, you get alerted, you don't have to sit there and watch it. But you're absolutely required. So don't resist, if you roll with the flow, you're going to be the ones that make the difference and make the project successful. So, well, Trevor, that's about it for this year. Do we have any other questions? Nope. All right. Well, I'm going to turn it back over to you, sir. And I'll ship you this presentation when we're finished. Trevor, you might be on mute.
You're right, I'm on mute. Sorry about that. Yeah, we've got a comment. Didn't Microsoft just have a major server outage, Outlook and Teams and things like that? So
Yeah, see, that's what scares me a little bit. And that's Teams. How many people use that? I use Teams. So yeah, that would affect us too. The good news is you're not getting any emails, right? So you get that reprieve, that little buffer. I mean, there's always a positive.
okay.
Hey, Scott, one quick question. You said system of record cannot be on both sides. So what is your experience like when they move, when they're streaming data? Is that the big institutes are doing reads from cloud and coming for updates to mainframe? What is your experience?
Yeah, that's the first step, usually, exactly what you just said. So you'll take and stream the data and move the query workload down to the cloud. But any updates can't be done on both sides. Should not be done. Now, you can do it, but what customers are doing are taking like subsets. Like they'll take in your case, a client ID. You might have client IDs 1 through 100 or something. I'm just throwing that number out. The system of record for those guys is on the cloud, but everybody else is on the mainframe. That's okay, right? Just make sure not to update that set on the mainframe. Don't do it. Because if you withdraw $100 on one side and withdraw on the other side, those replications are going to go back, overlay if you don't have collision detection. And even if you do, then they're both right and they're both wrong. It just shows you withdrew $100, not $200. Right. So that's number one rule. Anybody who violates that is you're in big trouble. So don't let it happen, man. Just don't. It's going to save you guys a ton of time.
Gotcha.
Okay, well, Momar Fall has got his hand up. So if you want to speak now.
Sure. Hi, Scott. How are you?
Good.
So you mentioned on your slides that some companies are getting ready to turn off their mainframe, and the migration from mainframe to cloud is going faster than ever. On the other hand, we do hear some people saying that, oh, mainframe is not going anywhere. So my question to you is, for people with fairly young, new experience to the mainframe / IMS or mid-level experience, like how do we position ourselves or retool ourselves for this ever-changing landscape? Thank you.
That's a good question. I agree with you. I don't think the mainframe's ever going to go away. I think there'll be a use for it, even in the larger companies. Now, some people have that mandate, the mainframe needs to go away, period. And by God, whatever it takes to do. Well, we're finding that it's going to be just less of a footprint, right? So less MIPS. As a newer IMS person, if you're a young guy, you're sitting really good right now, because the rest of us are not, we're a little more aged. It helps to understand how the cloud works and all the components. If you have a little sandbox, you can play. A lot of the stuff ends up hierarchical, like even like JSON. The format is hierarchical, so it fits really well with IMS. That's what I would do if I were worried about the mainframe going away and I want to keep one. You're not going to have to worry about your job, because if you want to stay with the same company, then retool to the cloud and just understand the monitoring's cool. Like I said, the overall framework, understand how, the EC2s work, understand containers. Containers are huge, Kubernetes, Docker, everything runs in containers. So just understanding the framework is like tiny little mini LPARs, if you will, / started tasks, give or take. I mean, the more you can associate yourself with that, the better. If you're not worried, about working for the same company, you're going to have the IMS demand is huge. I mean, huge. So you're going to be fine, even Z skills in general, right? So I don't know if that answered your question, but it's a little bit of both, right? Depends on what you want to do. And right now, I mean, if it were me, I'm not going to learn cloud that. I understand cloud, but I'm not going to go down there and spend time playing around with different things. But I will log on to TSO, like equal 3.4. So next question.
Yeah, we've got a question from Susan Rovel-Ricks.
Yeah, hi, Scott. Thanks, Trevor. So when the IMS catalog with fully managed ACBs, that is no macro path, relieves some of this requirement for understanding hierarchic architecture, because the DBAs would be writing DDLs instead of, updating macros and running gens, and the apps are, using SQL through their APIs, and most apps already know how to write APIs. So I would, I'm kind of curious, do you see, I'm very anxious to get the IMS catalog fully implemented. But I'm wondering if you see a lot of companies doing that. I mean, it just seems like a no-brainer to me, but then again, I'm an IMS DBA, so there you go.
It is, Susan. It is. The catalog makes things a lot easier, because if you give somebody a DBD gen, source, and say, here you go, this is the relationship, and they're going to go, oh my God, what is that? Right? The catalog certainly makes it better, right? You're still going to have copybooks. I mean, that part, that when you replicate it, but at least the way we're architected, you don't have to worry about that. We're going to auto generate the JSON based on the copybook, right? And redefines is all handled. So it's really a streaming utility. It's not so, but to understand the relationship, yeah, for sure, the catalog helps. What we're not seeing a lot of deployment though. I mean, most of the customers are still, they use managed ACBs, but everything else is not there yet.
Yeah,
It's still been a slow adoption, really slow adoption of the catalog.
Yeah, I don't understand it. I get that there's some negotiation required with the apps to pull in the copybooks and get the copybooks in the catalog, and I think that's the way to go. But I don't know. Just thanks for your 2 cents. I appreciate it.
Yeah, you're welcome. But I think you're going the right path, both. I mean, catalog makes things easier for sure.
Yeah, I've got a question for Sven Twenke. He says, in the big companies, I don't see the possibility to move off the mainframe by now, i.e. in a bank, the daily batch runs in a very restricted time frame. With moving this to the cloud, the batch wouldn't be able to do the work of the day in a day.
Exactly. That was the concern that everybody has, right? For let's take the monster posting, for example. That's always the big one. You're right. Where you have 6 hours, and you do in 6 hours what most people do in a month, right? Over 500 million updates or so, maybe more. How's that going to work in the cloud? It comes down to the IO. If the IO is microsecond level IO, you can do that in 6 hours. In the cloud, your millisecond, it's going to take 25 hours to do 24 hours worth of work. Your batch cycle, that's not going to work. And so my thought is you need to just rethink the whole thing. Traditional batch not going to work. So my thinking is you do these little asynchronous, well, say if you do a transaction, there's a little mini batch that happens after that. So you're kind of doing mini batch after the transaction, and in the end, cut down your batch cycle. They're going to have to rethink that whole process, because traditional batch just won't fly. Like you said, absolutely won't. It just comes down to, IOs and how long it takes for each one.
Okay, I've got another one asking for your opinion. Jocelyn Hamill says, when will the IMS catalog be mandatory?
That I don't know.
That
IBM's
is
been trying to do
IBM.
that for a while. That would be a question for any IBMer on the call.
So far,
Or
no date.
maybe, sorry?
So far, no date. We're
That's what
working
I've
with
heard too.
IBM, but so far, no dates yet.
I think they're getting pushback from the big companies a little bit.
Yep.
Getting some, and it's the big ones, right? You know, the banks and the insurance. They're getting pushback. The guys who do stock trades. There's a lot of pushback. And that's why people are trying to find a way off. That's one of the reasons, but IMS is so fast. I mean, like to your point earlier with the batch cycle, yeah, IMS batch cycle, what's faster, right? I mean, really to do what it does in 6 hours or 4 hours, it's pretty impressive, right? So how are you going to replace that? Well, Micro Focus IMS is not that tool, right? It's a okay tool. It's a good functional tool. It's not going to get you that kind of performance. So they might find that they might not be totally be able to move off the mainframe. We don't know yet. It's still kind of like nobody's gotten that far, the big ones, right? That I've been involved with anyway.
Interesting.
And many are just getting started.
Yeah. Okay. I will move on because we're over the hour mark.
Okay.
If anyone's got any other questions or you think of later, you can email me and I'll pass them on to Scott, and hopefully he'll get back to you fairly promptly. So can I say thank you very much, Scott? And as we're a virtual user group, please assume that you're now hearing a virtual round of applause from us all.
Thank you, Trevor.
very much.
I always enjoy this. So we'll see what happens next year.
Yeah, I'm
Right.
sure we'll have you back. Well, hang on, Nancy Campbell's just put her hand up. Do you want to speak, Nancy?
Oh, no, those are clapping.
Oh, clapping. Sorry, hand at the side. Yeah, okay, brilliant. Yeah, you just got to clap. Okay, let's share my screen and let's press on. So news, haven't got any articles and blogs. It just hasn't been anything on the IBM site since November, and I haven't found anything anywhere else. So let's move on to coming soon. So we've got Dusty Rivers, used to be at Aptigent, but has recently changed. He'll be speaking on the 18th of April, so put that date in your diary. And then on the 6th of June, we've got James Martin from Rocket speaking again. So put the 6th of June in your calendar. Yeah, we're still looking for co-sponsors for this user group. So if your company think that's something you'd like to do, then get in contact with me. And that's my email address in case you haven't got it in a million newsletters, etc. from me. And I just wanted to mention the Arcati Mainframe Yearbook. I know a number of people did the survey this year from this group. So the brand new Arcati Mainframe Yearbook is available. It is completely free and it's a PDF, so it's an easy download. And that's from iteched.com/Arcati. We usually get about 21,000 downloads or similar number to that. So it's there. Yeah, just a reminder, we're all over social media. If you do tweet or anything, the hashtag to use about this event is #virtualims. And the YouTube logo is there because a recording of today's session will be on YouTube later. Okay, well, that's all for this meeting of the Virtual IMS user group. Can I thank you all for attending? And I particularly want to thank Scott Quillicy for his presentation today. Really interesting. That's it. Thanks to BMC Software for sponsoring our user group, of course. And yes, thank you all very much for coming along today. And I look forward to seeing you on the 18th of April. So thank you all and goodbye.